Welcome to yet another video on SRID Cloud. In this video, I want to talk about InterVRF NATing, dynamic NATing, that requires VASI, the VRF aware software interface. So let's get started. Here is the topology, and if you looked at my other videos, you should feel very familiar with this one. There is a network on the bottom left side, 10.140.40.50, and there are a couple of PCs, and there's a switch on it. So these are all on VLAN 1000, and there is a trunk port from the switch to the core router, and the core router is in turn connected to an edge router. So this is all these things form the inside of a data center. Then the edge router is connected to an external router that customer may have, and there is another network 10.140.11.0 connected to that router, and there's a switch and PC on that network as well. That's very simple. There are no VLANs or anything like that. And now going into the details, let us look at the core router configuration. Let me make it a little bit bigger. So let's take a look at the runtime configuration. There is a VRF defined on this particular router, core router, and I call it as VRF A with the address family IPv4 turned on. And then there is a port channel, and that port channel is attached to the Gigabit Ethernet 1 here using the channel group keyword. There's a sub interface on this port channel 1.1000, and it is in the VRF A VRF, and it has IP address 10.140.45.1, which acts as a gateway for the 10.140.40.50 network on which the PC1 and PC2 are placed. And there is another port channel number 2, and this is actually attached to Gigabit Ethernet 2, which is going towards the edge router. And there is a sub interface on that as well, port channel 2.1000, and it is also in the VRF A VRF, and it has an IP address 172.16.16. So this acts as the one end of the tiny network between the core and the edge routers, the 172.16.14/30 network. And there is a BGP set up between the core and edge, and on the core router, the BGP setup is fairly simple. There is address family IPv4 for VRF A VRF, and the neighbor is 172.16.15 on the edge router, and whose ASN is 66999, and 65999 is the ASN of the core router. And there is a default route on this VRF to send everything, whatever that is not known, to 172.16.15 on the edge router. That is pretty much the configuration on the core router. Now let us take a look at the external router instead of going straight away to the edge router. So this is the external router. You can think of it as a customer router connected to the data center. And let us look at the run configuration on that. It's very simple. There are no VRFs, there are no VLANs or anything like that, no port channels, nothing. It has Gigabit Ethernet 1, that is 10.140.12.129. There is a tiny network between the edge router and external router, and 129 is the IP address on the external router side. And on GI2, there is an IP address 10.140.11.1, and it acts as a gateway for the 10.140.11.0 network connected to the external router. And there's nothing on Gigabit Ethernet 3 or 4. And of course, there is a route to 10.140.45.0 network on it through the 10.140.12.141 IP address. So this is to facilitate the return trip of the NAT operation that we will see later. So this is the route on the external router to send traffic back to 10.140.45.0 via this 141 IP address on the edge router. Okay. And that is pretty much the configuration on the external router. And now we need to look at the edge router. This is where the NATing operation takes place. So this is the runtime configuration of the edge router. Let me make it spacious. Okay. In this router, the edge router, there is a customer VRF as well as the VRF VRF. So the customer VRF is for the connectivity from the edge router to the external router, and the VRFA is to connect the edge router with the core router. And part of it we already saw while looking at the running configuration of the core router. And here is the port channel number 1. There's only one port channel here that is connected to the Gigabit Ethernet 1, which is towards the core router with a channel group keyword. And there is a sub interface on this port channel 1.1000, and it is on VRFA, and its IP address is 172.16.15. This is the same IP address we used while defining the BGP on the core router. This is the neighborhood for the core router's BGP configuration. And on the Gigabit Ethernet 2, it is under the customer VRF straight away without any port channels, and its IP is 10.140.12.141. And then here is the interesting part. In order to perform NATing, dynamic NATing or static NATing between two VRFs, Cisco requires that you use VASI. VASI stands for VRF Aware Software Interface. So the trick is create a couple of VASI left and VASI right interfaces. So VASI left, and put it on the left side VRF. In our case, it is VRFA. And the VASI right, put it under the right side VRF. In our case, it is customer. And these two are connected together with a /30 network. 10.1.1.1 and 10.1.1.2 are the two IPs from that network. And the mask is 255.252. This setup, the VASI left and VASI right, helps to achieve the NATing operation between two VRFs. And then, of course, there's a BGP on this edge router that is for connecting to the core router and then distributing the networks. The address family IPv4 VRF VRFA, there is no BGP on the customer VRF. And the neighbor for this VRFA address family in this BGP is 172.16.16, which is on the core router. And it is set up as a remote as 65999, which is the ASN of the core router. And then the final part of it, there is a ACL defined here. So in this ACL, this is an extended ACL, by the way. I have added permit statements for TCP, UDP, and ICP protocols for two different networks, or I should say two different paths. Both of them are using the 10.140.45.0, which is here inside the data center, as the source network, connecting to both the 129 address, the gateway of the external router, as well as the PC3 on the 10.140.11.4 network. The first one, let me go back to that. The first set actually, the 10, 20, and 30 are not really needed because the PC1 and PC2 will never access the router, external router at all. No application workload running under PC1 and PC2 will require anything from the router. Most importantly, the application workloads running under PC1 and PC2 would like to talk to PC3. So the ACL rules 40, 50, and 60 are the important ones. The 10, 20, and 30 are not really required. I added them for debugging purposes. And then a pool is getting created. This pool has got only one IP, 10, 140, 12, 150. So this IP is actually coming from the network between the edge and external router. The 10, 140, 12, 128, 25 is the network between the edge router and external router, and out of which dot 141 and dot 129 are already taken. So I used dot 150 as the pool IP address. Let me get back to that view again. And if I desire, I may set up this pool with 100 IPs, 150 all the way up to 250 in the 10, 140, 12, 128/25 network. But for this particular video purposes, I just picked only one. So there's only one IP derived from this network and used in the pool configuration. And then here is the dynamic NAT statement. This is actually on the customer VRF, the right side VRF, and using the pool and the ACL 100. And then there are a bunch of IP routes added. The first one is to make the VASI left understand the 10.140.11.0 network via 10.112, which is actually the VASI right IP address, if you noticed carefully. Let me go back. And you can see the 10.112 is actually a VASI right IP address. And then there is another IP route in the same VRFA for the 10.140.12.128 network as well, which is the network between the edge and the external routers. And that is also going through 10.112 as the next hop for this route. Both are defined on the VASI left interface. And then, of course, there is a default route on the customer VRF to send everything to the gateway on the external router, the 129, which is nothing to do with the NATing or VASI left or right that we are talking about. This is like a general statement that we do from the edge router, send everything that the router does not understand to .129 IP on the external router. And finally, here is the route statement. This is for return communication for the NATing operation. A route is added in the customer VRF with IP address 10.140.45.0 on VASI right with the next hop as 10.111, which is the VASI left IP address. Okay, so with this setup, let us try to go to PC1 and then try to ping the PC3, which I think I've already done, as you can see on the screen, and it works. Now let us see something concrete. I want to make sure that the NATing operation is actually happening. So for that, let me go to the second router where the NAT operations are performed, and let me do show IP NAT translations, and you can see the translations are all here, and the translations are for the 10.140.45.3 IP address, or even .2 or .3, and it is translated to 10.140.12.150 as we required. This is the IP from the pool. Let me do this. So the IP address of the PC2 is 10.140.45.3. Let me go to PC1 and then try to do the same thing. And while that is going on, let me try to do the network IP translation. You can see it is actually .2. And let me do this again. And then do this again. You'll see both 2 and 3 here. So network traffic from PC1 and PC2 are going through the edge router, where the IP is getting translated, the source IP is getting translated into 10.140.12.150 and transmitted all the way to the external router, and then the reply comes back to the edge router, and where the IP address is getting replaced from the destination IP actually getting replaced with 10.140.12.150 to 10.140.45.2 or 3, depending on where the traffic originated to begin with. So now let me show you one more thing. Let me go to this link between the edge router and the external router, and then launch Wireshark and look at the ICMP protocol only. Let me make it bigger. And now I want to go to PC1 or PC2 and then do the pinging again. And as you can see, this is too tiny probably. You can see the source IP is actually 150. It is not 10.140.45.2 or 3. Let me go to PC2 and do the same thing again. And as you can see, for this traffic also, the source IP is 10.140.12.150, the NATed IP. And now let me, do we really want to see this? Let's do that. Let me look at the traffic between the edge and core router and see how that looks like. Hope you can see this. It looks very tiny. Let me go to PC1 again. So here there's no reference to the NATed IP at all, because this is being captured before the NATing happens. This is between the core and edge router. So here the IP addresses are all 10.140.45.2 and 10.140.11.4 on the other side. So let me, for the sake of completion, let me do the same thing with PC2. And you can see the same thing. It is 10.140.45.3 and to 10.140.11.4. So I think this is very clear now. So here's a summary. So there is a VRF on the edge router towards the core router, and there is VRF A, and there's another VRF, the customer, towards the external router. And we need to perform NATing operation between the two VRFs. If one side is global, the other side is also global, then performing NATing is very, very easy. And even if one side is VRF, the other side is global, then performing NATing operation is also relatively easy. But when there are VRFs involved on both sides of the NATing operation, the IP NAT inside and then IP NAT outside, then there is a little bit of trickery that you need to do, and that involves VASI, the VRF aware software interface. So let's go to this edge router one final time, then look at the configuration to look at the actual VASI operation. So here is the interface, VASI left on one of the VRFs, and here is VASI right on the other VRF. And let's not worry about this BGP. And there is a ACL being set up, which is nothing to do with the NATing at all actually. But anyway, this ACL helps to filter the traffic at the host level on the destination. And here is how the pool is created, because dynamic NATing requires a pool. And this is how the dynamic NATing is set up with the overload keyword on VRF customer, the right side VRF, using the pool that got created in the above line and the ACL list number 100 created here. And these out of these four, three of them are very important for this operation. The InterVRF NATing, VASI left one and VASI right one. So routing has to be done. The routes have to be added on VASI left and VASI right one, so that internally inside the router, the traffic can flow from outside into VASI left and then to VASI right and then to the physical interface that is going to the other end. So I hope you understand the NATing required for, the setup required for NATing between two VRFs, which is a little bit tricky and took a while for me to figure out actually. So have a wonderful evening, or day, or afternoon, wherever you are. And I will produce a lot more videos in near future on similar topics. And bye for now.